This video is about absolute values. So let's start off with a definition. What is an absolute value? What does it mean? So really what it means is the distance from zero. So if we were to consider a number line and we had 0 in the middle and say we had positive 3 here and negative 3 here. So I know that negative 3 and positive 3 are not equal. However, they're both 3 units from 0. So absolute value doesn't care about the direction, whether I'm going to the left or to the right of 0, it just tells me how far away I am from 0. So in other words, the absolute value of negative 3 is the same thing as 3. Okay, so let's see that as on a graph. So if I have the line y equals x, so we know that's the line going through the origin with a slope of 1. Then the graph y equals the absolute value of x means that everything that's below the x-axis is going to have to pop up above the x-axis. So it'll have to be in the positive y range because I can never end up with a negative value here for y in this equation. So I still have this piece over here on this side, and then this stuff from the below the x-axis is going to bump up and it's going to look like a V. So in other words, I could write a piecewise function for this. So the absolute value of x is going to be equal to x when x is greater than or equal to 0. So we see that line here, the pink one, the pink piece, and then it's equal to negative x when x is less than 0. So we see that here, the blue line. Okay, so that's how we're going to solve absolute value problems algebraically, is we're going to have to split the absolute value into this piecewise function with the positive part and the negative part. So for example, let's say we have to solve for x in this equation. So I have the absolute value of x minus 5 is equal to 3. So what I want to do is I need to consider both the positive and the negative of this absolute value. So I'm going to split this into two pieces. So I have the positive, just x minus 5 is equal to 3, and then I have the negative piece. So I put a negative sign in front and make sure that you have brackets around everything that was in the absolute value is equal to 3. Okay, so I have the positive and the negative piece. So then I can solve each piece separately. So in my first equation, I have x minus 5 equals 3. So that's easy to see. If I add 5 to both sides, I end up getting x equals 8. Oops. And then in the second part, in the negative one, I have to do a little bit extra. I have to divide through on the left by that negative sign. So I have negative x plus 5 equals 3. Solving for x here, I'm going to subtract 5 from both sides. So I have negative x equals negative 2. And then I can divide both sides by a negative 1, so these become positive, so I get x is equal to 2. So I have two answers there for x. X could be 2 or x could be 8, and I can see that if I put in and I want to check my answers. So when x equals 8, I have the absolute value of 8 minus 5, which will be 8 minus 5 is 3, so it's the absolute value of 3, which is just 3, so that's good. And then when x equals 2, I have the absolute value of 2 minus 5, which is the absolute value of negative 3, which we saw before, is also equal to 3. So both 8 and 2 satisfy this absolute value equation. Okay, let's see another example. So a little bit more complicated. I have 2 times the absolute value of 2x plus 3 minus 7 equals 5. So the first thing I want to do is I want to isolate the absolute value. So I have just the absolute value on one side of my equation and then everything else on the right or on the other side. So the first thing I'm going to do is I'm going to add 7 to both sides. So I get rid of this guy. So I have left on the left hand side 2 times 2x plus 3 in absolute values equals 5 plus 7 is 12. And then I need to get rid of this 2 that's in front of the absolute value, so I'm going to divide both sides by 2. So now I have absolute value of 2x plus 3 is equal to 6. So now I've isolated that absolute value. That's all I have on the left-hand side. So now I can split it into the two pieces. So I have my positive piece, which will just be 2x plus 3. And that's equal to 6. So the right-hand side isn't changing. It's not in an absolute value. And then the negative, so negative, and then remember brackets, 2x plus 3 is equal to 6. So I can solve the first equation. I have, to solve for x, I'm going to subtract 3 from both sides. So I end up getting 2x equals 6 subtract 3 is 3. And then I divide both sides by 2. So I get x equals 3 halves. Oops, I wrote it upside down. Okay, and then in the second equation, I need to first distribute that negative sign through the brackets. So I have negative 2x minus 3 equals 6. And then I solve the same way as I did above. So I'm going to add 3 to both sides. So I have negative 2x equals 9. And then I divide both sides by negative 2. So I get x is equal to negative 9 halves. Okay, so again, two answers there. I can have x is 3 halves or x is negative 9 halves. And if you wanted to verify that for yourself, you can plug both those answers back in for x into your original inequality your original equation with absolute value and see that it satisfies that both 3 halves and negative 9 halves will satisfy that. Okay, thanks for watching. Good luck with the assignments.